Dear students, today we will discuss about the rigidity modulus of the material of the given experimental wire by torsional oscillation method using MOSES. In this connection, the question is, explain the determination of rigidity modulus of the material given by the torsional oscillation method using MOSES. Already we have discussed the rigidity modulus of the material of the given wire without MOSES method. Now we are going to discuss using MOSES. A thin experimental wire of length L and the radius A is fixed at one end with check nut and the another end is passing through the center of the circular disc of mass capital M, and the radius of the disc is capital R, and the moment of inertia produced by the circular disc is capital I. Now a torque is set in the disc and it allowed to oscillate, and its period of oscillation is taken. So the torque is given like this. So it starts to oscillate from the center to here, and then again here, and then here. It is taken as a single oscillation. Here to here, and then here, and again it reaches the center. So the oscillation is counted as one oscillation. Now a symmetrical mass, small m, the two symmetrical masses of each mass m is placed along the diameter of the disc here at the equal distance. The d1 is the distance from the center of the mass to the center of the disc or the axis of the wire, and here also the d1. So the distance between the center of this mass and the center of this mass is taken as 2d1. Now the disc is rotated and then released, which executes the torsional oscillation about the axis of the wire. From this, the period of oscillation is determined. That is, T1 is equal to 2 by root I1 by C, the first equation, where I1 is the moment of inertia. So T1 square is equal to, squaring this equation, we get 2 pi square I1 by C, where I1 is the inertia of the whole system. It contains the different components. I0, it is the moment of inertia due to the circular disc, and small I is the moment of inertia of the each masses. The small I is due to this mass, and another I is the moment of inertia due to this mass. Each mass is about the parallel axis passing through the center of gravity. So according to parallel axis theorem, the moment of inertia due to the whole system I1 is equal to I0 plus 2 small I plus 2 small m d1 square. It is taken as equation 2. Now the two masses, the m1, the m and m, are kept at the farthest distance d2, that is the distance between the center of the mass and the center of that is the axis of the wire is d2, small d2, and another d2 from the center of the wire and the center of the mass. So the distance between two masses is 2d2. So now this whole setup, that is the disc and the two masses at the farthest distance, is said to oscillate, and its corresponding period of oscillation T2 is determined, and the moment of inertia from the period of oscillation is calculated. I2, the moment of inertia due to the second position whole system. I2 is equal to I naught plus 2 small I plus 2m d2 square. It is taken as equation 3. On squaring the T1 square, already we know that T1 is equal to 4 pi square I by C. So the value of I is substituted here. So T1 square is equal to 4 square by C into I naught plus 2I plus 2m d1 square. Similarly, the T2 square, the period of oscillation for the second position, T2 square is equal to 4 pi square by C I naught plus 2I plus 2m d2 square. Now subtracting these two equations, we get this, and then it is modified into T2 square by T1 square is equal to 8 pi square m by C d2 square by d1 square, and then the value of C is substituted here. Already we know that C is equal to pi n a power 4 by 2n. On modifying this equation, we get n is equal to 16 pi l m by a power 4 d2 square by d1 square by t2 square by t1 square. Now the variable quantity here is the length and the period of oscillation. That is the time. So these two variable quantity is taken separately. So n is equal to 16 pi m d2 square by d1 square by a power 4 into L by T2 square by T1 square Newton per meter square. From this equation, from this expression, we can determine the rigidity modulus of the material of the given wire by using symmetrical masses method.